Alright, here we go, guys. Welcome to another exciting installment. So the first thing we do, it says find a given the function f of x is continuous. So they're telling us it's continuous. So you want the left side to equal the right side. So you plug in a 2. So 2 squared equals a times 2 minus 4. So 4 equals 2a minus 4. I guess you don't have to necessarily write that again. Plus 4 plus 4. 2a equals 8. So you have a equals 4. And then there it is. And let's go to the next one. This time they ask you to find the values of a and b to be continuous at 1 and at 7. So what you do is you set these two equations equal to each other first at 1. So plug in a 1 for x. So a times 1 minus b equals 30 times 1 is 30. And we're still good. Alright, the next one. Now at 7, you want to equal these two in blue together. So plug in a 7 into x. So 30 times 7, that's 210. Countdown city. Equals, let's see, 7 squared is 49. So 49b minus a. So now that you have two equations, guys, now we're just going to solve. So I'm going to solve it in a neutral color here, so green. So I'm going to solve for, let's see, what am I going to solve for? I'm going to swap the a and the 210. So I'm going to say that a equals 49b minus 210. And I'm going to plug this a in here. So now I'm going to say 49b minus 210 minus b equals 30. I'm going to move the 210 over. So 49 minus 1b is a 48. So 48b equals, and then 210 and 30 is, what's that, 240? And then go ahead and divide by 48. So you get that b is, let's see, 240 divided by 48. Oh man, hold on. Sorry guys, technical difficulties. 240 divided by 48. And I got 5. So now that you know that b is 5, you can just plug it in right here. So a minus 5 equals 30. So a has to equal 35. And there it is. Alright, let's go to the next one. Let's see, given that f of x equals this function, define the function f of x at 5 so that it becomes continuous. So first, multiply by the conjugate. You're trying to get rid of that square root up there. So I'm going to go square root of x plus 4 minus 3 over x minus 5 times square root of x plus 4 plus 3 over square root of x plus 4 plus 3. So when you do that, guys, this is like multiplying by 1. Because you can see it's the same over the same. And then when you multiply across here, it's like saying difference of squares. So I'm going to have on the top, I'm going to have x plus 4. And then negative 3 times the positive 3, that's a minus 9. And on the bottom, do not distribute. Leave it like this. See? So when you do that, now you get this. X minus 5 cancel out. And now you can do direct substitution. Plug in a 5. So if you plug in a 5, you get 5 plus 4, which is 9. The square root of 9 is 3. And 3 plus 3 is 6, so 1/6. In order to make this function continuous, you need the y value to be 1/6. All right, let me take a quick pause, guys. Hold on. All right, I am back. Let me make sure. Yep. All right. Here we go. Can the intermediate value theorem, that's IVT, be used to show there is a solution to the equation f of x equals 0 on the interval 1 or 2 if it is my function? All right. So let's find out what f of 1 is. 3 times 1 cubed minus 5 times 1 squared plus 1 minus 3. I think we can do that without a calculator, guys. 3 minus 5, that's negative 2, plus 1, that's a negative 1, minus 3, that's a negative 4. So now, I'm going to see what f of 2 is. If f of 2 is positive, then definitely f of x equals 0 somewhere between 1 and 2. And if f of 2 is negative, then we have no real evidence that f of x was 0. Was it 0? Maybe, but we don't have any real evidence that f of 2 is negative again. So here we go. 3 times 2 to the third power minus 5 times 2 squared plus 2 minus 3. 2 cubed is 8. 8 times 3 is 24. And then 2 squared is 4. 4 times 5 is 20. So 24 minus 20 is 4. And then I'm going to add 2. So that's 6. And then I'm going to subtract 3. So that's 3. Did I do that right? 24, let's see, 2, 8, 16, 24. 2 squared, 4, 5, 20. And then 2. Okay. 4. I think I did it right, guys. So, because I had a negative at f of 1 and a positive at f of 2, yes, definitely crossed the line, the x-axis, because, you know, the y value is 0 on the x-axis. We do the same with this one. Here we go. I find f of 3. Square root of 3 times 3 squared minus 6 times 3, and then minus 2. So let's see what this is. 3 squared is 9, 9 times 3 is 27, and I'm subtracting 18. Let's see, 27 and 18, that's 9, and the square root of 9 is 3, so 3 minus 2, so I get 1. So let's see what f of 5 is. F of 5, square root 3 times 5 squared minus 6 times 5 minus 2. So I have 5 squared is 25 times 3 is 75, and then 6 times 5 is 30. So I have, let's see, 30, 40, 50, 60, 70, square root of 45 minus 2. Now 45 breaks down to 9 times 5, so you have 3 square root of 2 minus 2, which is a positive number. So I was at 1, and now I'm at 3 square root of 2 minus 2, which is some positive number. So no, IVT does not guarantee that this equals 0, because, look guys, I didn't go from positive to negative. I stayed at positive. So look, that's this one. Positive, positive. All right, let's go to the next one. Solve inequality for x given that. So what I'm going to do, guys, first, okay, so they want us to make sure, they want this to always be larger than 0. So pretty much what it's saying is, when is it positive? I'm going to factor out a 2. I'm going to factor out a 4. 4 times 2 is 8, so I'm going to write it as 8x. Oh, I already factored out a 2, so that's not there anymore. X minus 4. And x minus, I believe that's a 7. Yeah, 7 times 4, 28. And I want that to be greater than or equal to 0. So, what I'm going to do now, sorry guys. What I'm going to do now is I'm going to get something called critical numbers. That means when this equals 0. This equals 0 at 0. This equals 0 at 4. This equals 0 at 7. All I did was this. 4 minus 4 is 0. 0 times anything is 0. 7 minus 7 is 0. 0 times anything is 0. And 8 times 0 is 0. So there it is. So I do something that's called rural tracks to many of my students here. So I'm going to put 0, 4, 7. And all I'm doing is checking whether it's positive or negative. So I'm going to substitute directly some number here. So to a number to the left of 0, like negative 1. 8 times negative 1 is negative. Negative 1 minus 4 is another negative. Negative 1 minus 7 is another negative. Negative times a negative times a negative is negative. Plug in a number like 2. Positive, negative, negative. Negative times a negative is a positive. Plug in a number like 5. Positive, positive, negative. So again, you get negative. And plug in a number like 10. All three terms are positive, and when you multiply them, it's a positive number. So there it is. So I want it positive. So between 0 and 4 and 7 to infinity. You can include 0 and you can include 4 because you're allowed to equal 0. There it is. All right, hold on, guys. All right, let's continue the good fight, guys. Solve the inequality for x given that, and we have this, so we want this to be negative now. See, because it says less than 0. So I'm going to get critical numbers. So critical numbers is where this function is undefined or equals 0. So it's undefined at 3, it's undefined at 9, and it's undefined, not undefined, it's 0 at 6. So there it is. I'm going to make my number line. So here's my number line. I'm going to put in, let's see, which one am I going to put first? 3, 6, and 9. Now understand, guys, that I can never equal 3 and I can never equal 9 because those are two vertical asymptotes. So notice none of my answer choices have a bracket on 3 and 9. That's just something to observe. All right, if I plug in a 0, 0 minus 6 is a negative, 0 minus 3 is negative, 0 minus 9 is a negative. So on the bottom, so I have, let's see, negative times a negative is a positive, that's on the bottom, and negative divided by a positive is a negative, so negative. If I plug a number like 5, I'm going to evaluate the denominator first, guys. 5 minus 3 is a positive, 5 minus 9 is a negative, positive times a negative is a negative, and the top, 5 minus 6 is a negative, and negative divided by a negative is a positive. In the bottom, now between 6 and 9, so like 7. 7 minus 3 is a positive, 7 minus 9 is a negative, positive times a negative is a negative. In the top, 7 minus 6 is a positive, positive divided by a negative is a negative. And if I have a number like a 10, positive, 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 well, everything's positive, so positive divided by positive is positive. I wanted negative values, so negative infinity to negative 3, negative infinity to 3 and 6 to 9, not including 6 or 9. So there it is. All right, let's see if we can go fast through these. Is it possible to have a function f defined between 4 and 5? Okay, it can always be defined anywhere and meets the given conditions. F is continuous on 4 to 5. Notice, no brackets. Takes on the values of 4 and 5, but does not take the value of 9 too. Yes. How does that graph look? It looks like this. Here's 4. Here's 5. I take on the value of 4 and 5. I'm going to say that this value is 4. I'm going to say that this value here is 5. And I'm going to say open circle. I'm going to say that is 4.9. 9 over 2 is 4.5. So there it is. I take every value. I take 4, I take 5, and I'm always 4.9. So yes, it's possible. It's possible to have a function f defined on 3 to 5, yeah, and meets the given conditions. Continuous, notice their brackets, has a maximum value of 5 and a minimum value of 5. If your max and min values are the same values, that means you just have a horizontal line. So here's 4, here's 5, and I just have a horizontal line at 5, and there it is. So yes. All right. Is it possible to have a function f defined on 2 to 4 and meets the given conditions? F is not continuous on 2 to 4 and takes only 2 distinct values. Yes, it's possible. So I'm not continuous. So I'm going to put a break at 3 then. So I'm going to do this. 2 to 3. And I'm going to say that that value is always 2 because it says only 2 distinct values. It doesn't have to be 2. It can be any value. And then I'm going to say, there we go. And I take only 2 distinct values. And I'm not continuous. So yeah. So these 3, guys, you're just going to have to think about it for a little bit. So just think about it and you'll be fine. All right. Hopefully you like that. Take it easy. Bye.